For this particular test, it merely has the label correlation, and you can double click on the label, by the way, to change it. I won't do that now because I don't believe in confusion, but you can double click on a correlation or any title of a table to change it to whatever you want. You could change it to correlations in Ansof's first class, or you can change it to correlations by Ansoff, that professor who's driving me crazy. Anything you want, you could change the label to by double clicking, but we won't worry about that now. Let's concentrate on the output. Again, no effort has been made to make SPSS output particularly friendly, so it's up to us to know about statistics and understand what we're doing. Here's the thing. When you see the output here, you're going to see it has the variable gender here. And it says it did a Pearson correlation. Now, SPSS is stupid. When you ask it to do a correlation, it's going to correlate each variable with itself and each variable with the other variable in the correlation. And that's what it did here. It correlated gender with itself. Literally, it correlated the variable gender that I entered with the same variable again. That's why, if you see what the correlation indicator is, it says it's a 1, 1.0. Any variable correlated with itself is going to be a perfect correlation. If I measure all your heights in here right now, and then I measure all your heights in here again, and I correlate the two variables, they have the same values on the two variables, and it's the perfect correlation. But SPSS is stupid. You would think it would be designed so that it wouldn't be correlating the same variable with itself, but it doesn't know how to do that. It merely correlates every variable with every other variable in a correlation. So you have to know what you're looking at. So you don't need to pay attention to when it correlates gender with gender. That tells you the correlation was 1. And because it's stupid, it doesn't really know what to do because it's a perfect correlation, which you almost never see, ever, and you will not see in the social sciences. And that is a blank for significance, so we won't worry about that. And the number of observations in our data set was indeed 8, so we're okay. Okay. Now, what you do need to pay attention to is it correlated gender with IQ. And remember, that was what we were interested in. This box over here is gender correlated with IQ. That was what we really wanted to know. What was the correlation between gender, male or female, versus the IQ scores in our data set? The first number up here tells you the strength or the magnitude of the correlation. The first thing you learn is the magnitude, and that's the top thing here. See, it says 0.795. Everybody see that?
Yep.
0.795. That was the correlation. Now, for those of you who have taken statistics with me or someone else, maybe you took it a while ago, what does a positive correlation between gender and IQ with 0.795, how would you express that? What would you say that correlation is? It's a positive correlation because it's positive. What does that mean? 0.795 between gender and IQ. Positive correlation means those who scored high on one variable tend to score high on the other variable. Okay? So you would express it by saying those who scored high on the gender variable also tended to score high on the IQ variable. And it's a 0.795 plus. Now, it depends on the discipline and it depends on where you are and what you're doing, but in absolute terms, this is a strong positive correlation. Any correlation you get in absolute terms, and it will differ on your discipline and whether you're dealing with finance or stock price prediction or whatever it is. This is a strong positive correlation because, as you may remember, a correlation can range from a -1 to a +1. And this is a plus 0.795, which means it's a strong positive correlation. That's the magnitude of the relationship between gender and IQ. The magnitude of the relationship between gender and IQ. And remember, how did we code the two variables? Remember, to understand the correlation that you got, you have to remember how the two variables you used in your correlation were coded. Does anybody remember, how did we code the gender variable?
Male were 1.
Right, males were 1, females were 2. So if we know that those that were high on the gender variable also tended to get the higher IQ scores, how would we express that in plain English? Because you're going to have to report everything you do in a good statistics report. You can't merely say, oh, it was a significant correlation, bye-bye. No, you have to explain what it means. So if we know what we know about how we coded our data, those that were high in gender were, who were the high ones when we coded the gender variable? 1 was male, 2 was female, so what does that mean? Female were the higher. So those that were higher on gender, okay, also tended to have the higher IQ score, because we know that for IQ, a low score means you're not as clever on the IQ test, and a high score means you're getting a higher score, and presumably you're doing better on the IQ test. So how would we express this strong positive correlation between gender and IQ? How would you say it in English? It's hard. You know, that's the funny part. That in statistics, it's no problem in SPSS entering data. It's no problem organizing the data. The problem comes when it comes to interpreting, and then you have to try to explain this. High on gender meant that those were the females because they were coded too. So those who were high on gender also scored higher on IQ. So something, if it's significant, we would say that something systematic operates such that those persons who were high on gender, in other words female, tended to have the higher IQ scores. And the plain English explanation is those who are female tended to have the higher IQ scores. It's not a perfect correlation, so we can't say it's true all the time, but it certainly is a tendency in the data. And that's why you notice what I had to do and what you'll have to do. You go back and remember, how did I code those variables? Now, I don't want to confuse our wonderful viewers at home, but I'll just say this much. If we had coded the gender variable in the opposite way, such that the females were 1 and males were 2, our whole result would be different. And I don't want to confuse you, but just to illustrate that you have to keep track, how did you code data to figure out how you interpret a result of a statistical test. So what we found out, strong positive correlation. Those who were high on gender, in other words, were coded 2 as females, tended to have the higher IQ scores. So that's the magnitude of the relationship in the variable. Now, the second thing you need to know is in SPSS, it will say SIG. SIG. That stands for an evaluation of statistical significance. For those of you who have gone through statistics, a real statistics class, that's the same thing and should have been labeled P or probability. It's the same thing as probability or P. But SPSS has its own esoteric, funny way of looking at things sometimes. So when you see SIG in statistics, in SPSS, that's the same thing as the probability number. And if you look over here, it says for this correlation, 0.795, the probability number is 0.018. Does anybody remember anything about probability in the statistics classes that you've suffered through or you've taken with me, in which case you've really suffered, though you got chocolate? Does anybody remember about how to interpret this part of a result? Because any test is going to have it. Any statistical test you run in SPSS is going to have this.